This is adding and subtracting linear expressions part 2. In part 2, our focus is actually going to be subtracting the linear expressions. So once again, a linear expression is an algebraic expression where the exponent of the variable is 1. So anytime we have an expression that has a variable of 1, or sometimes the variable isn't written at all, we can infer that that variable is a 1. Call it a ghost one. Sometimes it's there, sometimes it's not. So these are all linear expressions. A nonlinear expression is any expression that has a variable raised to a power other than 1. So here we have x to the power of 5. So this is a nonlinear expression. Anytime you see a variable in your expression raised to a power other than 1, it is not a linear expression. So let's take a look at a subtracting problem. So here we have 5x plus 6 minus the quantity negative x plus 6. So this is a little different because I'm taking these two quantities and I'm being asked to subtract them. But the rules really aren't changing. We still want to make sure before we solve our linear expression that we have changed everything to addition. So what I'm actually going to do is take this subtraction sign between my two expressions and I'm going to make it plus negative. Now that negative kind of just looks like he's weirdly hanging out. I can put a 1 in here. So it's plus negative 1. I can also stick a 1 here in front of this x. So now I'm going to go ahead, now that this is all addition, and start solving. So for this first quantity, I have 5x plus 6. Plus, I'm going to distribute this negative 1. And negative 1 times negative 1x gives me 1x. And negative 1 times 6 is going to give me negative 6. So I'm going to rewrite some of this. I'm going to rearrange it so that my like terms are together. So 5x plus 1x plus 6 plus negative 6. So my x terms combine to 6x. My 6 and negative 6 together is 0. And 6x plus 0 gives me a final answer of 6x. So the difference of these two quantities here is 6x. So let's try another one. So here are the quantity 7y plus 5 minus 2 times the quantity 4y minus 3. So I'm going to change this to add the opposite, so it's going to become a negative 2, and add the opposite, so this is going to become a negative 3. Now that it's all addition, I can start actually solving. So I have 7y plus 5 plus, I'm going to distribute my negative 2. So negative 2 times 4y gives me negative 8y plus negative 2 times negative 3 gives me 6. So I'm rewriting this so that my like terms are together here. My 7y and negative 8y gives me negative 1y. My 5 and 6 gives me 11. Before I write this as my final answer, I'm going to simplify a little bit more. I'm going to get rid of this unnecessary 1. So negative y plus 11 is my final answer. At this point, pause the video. Try these two differences on your own, see what you come up with, and when you're ready to check your answers, start the video again. All right, let's check these answers. So the first thing I'm going to do with this expression is make sure that I'm changing everything that I can into addition before I do anything else. So I'm going to make this plus negative, because it looks like a weird negative just hanging out there. I'm going to make it negative 1. And I'm going to make this plus negative 8. So I've got negative 3x plus 7 plus, if I distribute my negative 1 here, I have negative 4x plus, and distribute my negative 1 again, negative 1 times negative 8 is 8. So I'm just rewriting right now, putting my like terms together. So my two x terms give me negative 7x. My two constants give me 15. And this is as simplified as I can make this one. Negative 7x plus 15. Once again, always start by changing everything to addition. So this is going to become plus negative 5. Now I'm ready to distribute. Negative 2 times c is negative 2c. Negative 2 times 2.5, negative 5. Negative 5 times 1.2c is going to give me negative 6c. And negative 5 times 4, negative 20. So I'm rearranging here. So my two c terms are going to give me negative 8c, and my two constants are going to give me negative 25. Before I call this my final answer, I'm going to simplify this plus minus and just rewrite this as negative 8c minus 25. All right, let's do one more problem together. Let's take a look at a word problem. The original price of a cowboy hat is D dollars. We don't know. We're going to call that price of that hat D. So you use a coupon and you buy the hat for D minus $2. So your coupon got you $2 off the price. Then you take the hat home, you decorate it, and you decide to sell it, and somebody buys it for twice its original price minus $4, or 2D minus $4. They want an expression that represents your profit. Well, to find your profit, you would have to figure out what you sold the hat for, subtract what you purchased it for, because that was money you spent, and that will leave you with your profit. So the selling price for this hat was 2D minus 4. And I'm subtracting what I paid for the hat, which was D minus 2, in hopes of getting my profit. So I'm going to first change everything I can to addition. So add the opposite, it becomes negative 4. Add the opposite, I get a negative 1 here. And add the opposite, I get a negative 2. So now that it's all addition, I'm ready to do some simplifying. I have 2D plus negative 4 plus, I'm distributing my negative 1. So negative 1D plus negative 1 times negative 2 is 2. So I'm rewriting, I'm putting my like terms together. So the 2D and negative 1D leaves me with 1D. And my negative 4 and 2 gives me negative 2. So before I call this my final answer, I'm going to simplify a little more. I don't need this 1, so I'm just going to say D. And this plus minus is just going to be minus 2. So this is my profit right here. Well, my profit is actually the same as the price I originally paid. So I actually made as much money as I originally paid for the hat.